What's up guys, your boy here, and let's get straight to the lesson. So let's say I have line 1 in plane R. I'm going to draw another line. This line does not intersect line 1, but it's also in the same plane. These lines are co-plane to each other and don't touch. This is the definition of parallel lines. Lines are co-planars, which are in the same plane. Keep in mind that in plane R and that they do not intersect. So these lines can go off forever and not touch. This is in contrast to perpendicular lines, which are lines that are also co-planar but they intersect at a 90-degree angle. In other words, when they intersect, they form 4 90-degree angles. Skew lines are a special case. These lines do not intersect, but they're not parallel because they're not coplanar. Keep in mind, look how line 1 is in plane R and line 2 is in plane S. That's a special difference in skew lines. A transversal line is a line that intersects two coplanar lines at two different points. For this example, I'm going to use parallel lines for later on. So 1 and 5 angles can also be known as corresponding angles. These angles are pretty much in the same position. In other words, line 1 is on the left of the transversal line, also is line 5. Line 1 is above the above line 1, and also 5 is above line 2, so they're in the top left. The corresponding angle projection states that if two paired lines are cut by a transversal line, then they form congruent corresponding angles. There's another case. 3 and 6 can also be known as alternate interior angles. These angles are special. And to explain in a deeper sense, 3 and 2 can follow the definition of vertical angles, which means that 3 is equal to the measure of 2. 2 and 6 are corresponding angles. In reference to the conjecture earlier, when a transversal line intersects, they form congruent corresponding angles, which means 2 equals 6. So if I put that together, that means the measure of 3 equals 2 equals 6, which also means that 3 equals 6. This is the first half of one of the halves of the alternate interior angles. The other half is, since 3 is left of the transversal and 6 is the right of the transversal, also 3 is below line 1, 6 is above line 2, so they're exactly opposite to each other. In terms of position, 3 will be in the bottom left of the intersection at the transversal line, while 6 will be at the top right at line 2 in the intersection with the transversal line. The alternate interior angle conjecture states that if two parallel angles are cut by a transversal line, then they form congruent alternate interior angles. Have fun with that. That is the lesson for today.